Hello, everyone. You are welcome to today's lesson. And in today's lesson, we have a simple task. And that task is we are going to look at the solution to the class test on the topic sets. Sets. Okay, so in fact, it's the solution as well as what's the marking scheme. So basically, it's a marking scheme. Every marking scheme indirectly gives you the solution and guides you as to how to mark, meaning there will be marks assigned, okay, to your steps and your answers. Okay, so quickly, okay, let's look at what the solution to the first question. So this was the first question, question one. We were asked to simplify. We had a lot of them, but here I have A and B. Okay, the next page maybe will cater for the other questions and the sub questions under question one. Okay, so as usual, when you read question, make it a habit to underline the salient part. Here is simplify. Anytime you are given an expression, it's either you are asked to evaluate or simplify. So this one is the usual form. So we are not bothered because we are dealing with expressions. Okay, so at this point, nothing salient to underline here. Now, what do? We come and write, okay, solution. That should be the first thing that you write after you've underlined the salient part, if any. But here, realize that no salient part. So solution is what you are supposed to write. The test, okay, class test is not necessary. Okay, this is just to throw light on, but you are supposed to write solution. After solution, you have a major question number one. Okay, a major question number, is there anything that you could extract there? No. So you come to the minor question number A. Is there anything? Yes, this is what you were asked to simplify and must always be extracted. So you extracting this alone, just copy and paste will give you 1 mark. Take notes. Okay, now going by the advice I gave you, I told you that anytime you are asked to simplify, okay, any set, first of all, check whether the set that you have there, any of them can be reduced, meaning any of them is not in its basic form. And if you look at this radicand here, this set, the radicand here does not contain any perfect square apart from 1. Same for this. Okay, this one, okay, contains a perfect square apart from 1. Same, okay, this one, a perfect square apart from. So it means we can reduce this and equally reduce that. So your first step, which starts with equal to, if you start with implication, you are doomed. Because remember, equal to's are for the introduction of steps whenever you are dealing with an expression. And obviously, this is what? An expression. So this will be equal to, then what do? This must be maintained. You go and work on the one that must be reduced. So this equally must be kept. You come and split this one into the highest perfect square, then non-perfect square product. That's what we have here. You do same for this one. Okay, that gives us, so that will be M2. Then after that, now you know, reducing this, okay, you write all that you didn't touch. Now you come and you are simplifying this. Okay, these two. So if you simplify this, which will give you 2 roots of 3. If you simplify this, that will give you 3 roots of 3. So now you come and remove the first bracket. Okay, you should remove the bracket inside the bracket here before you go and remove. So it means indirectly we are not done simplifying this. So what do? Now this will come and multiply this, which will give you 10 roots of 3. The rest kept. Okay, this will also, it's not completely simplified because we want it to be 1, okay, factor. So in this case, you multiply, that gives us exactly what you have here. Okay, take note of this. However, you should note that this bracket, okay, shouldn't be here. Take note of that. This bracket shouldn't be here. Because once you are removing this bracket, the outer bracket will go and this one will go and this one will go. This is the inside and the outer. So take note. So at this point, what do? Now you go, you can see that by simplifying what you have in brackets here, this term, okay, you realize that these two now becomes like terms. So you can equally combine. So don't go and expand. Check whether what you have them, after simplification, they are like sets for you to combine. And we realize that they are like set, radicand 3, radicand 3. So we can combine by combining their coefficient. So it will be 4 minus 10, which will give us minus 6 roots of 3. Then now you finally come and remove your final bracket. So it will be minus 2 times minus 6, which will give you 12. Then it will be root of 3 times root of 3. That will give you root of 3 squared. Someone equally can write root of what? 3 times 3, which is 9. So root of 9. Then you have one more step. You will now come and reduce the root of 9 to, okay, 3. then you end up getting this. Now you know that the next step when you remove the bracket here, you end at what? Your final answer. So at that step, you have your conclusion drawn. So this time, this which will give you 36 then plus 9 roots of 3. So that will give you A1. An alternative method, okay, is that you can choose to remove the brackets, only that without a before simplification of any said, reducing any said, only that you will be dealing with bigger values, but you shouldn't be too worried if you do so. So in this case, okay, if I remove the, after extracting this, which will still give you B1, if I remove the bracket here, I'm going to get this times this, which will give me negative 2 times 4 minus 8, then root of 3 times root of 3, that will give me 3, or root of 9. Then you come and multiply this and this, which will give you minus 2 times minus 5, which will give you 10. Then root of 3 times 12, which is 36, then plus this one, okay, you are supposed to reduce. You don't have any option. So you reduce this just as I explained here. Then now at this point, you remove this bracket, it gives you this. This one, root of 36, 36 is a perfect square. So that will give you 6, so 10 into 6. And this one too, you are working on it. So you write this as root of 9 times root of 3. Root of 9 is what? 3. So it will be 3 root of 3. Then at this point, what do? Remove this bracket, and the next step, you have to combine these two like terms. Okay, and if you combine, you end up with the same result. So the whole of this will be 8 marks. Okay, this equally will be A. So if you use this approach, you are supposed to get 8 marks for A. If you use this approach, you still get the same 8 marks. It's the same question. So irrespective of the approach or method that you go, okay, you need to get the same marks. Okay, so that will be it for question, okay, 1A. Now let's look at that of the B. Okay, B, this is what we are given, so you extract. Okay, you can see that I decided not to write the given, which I've told you, you can equally choose not to. Okay, so, but you need to extract this. And I remember I told you that, okay, before you think about rationalization, expand first. Maybe after expansion, rationalization will not be necessary. So I am going to heed to that advice. So someone can write this is equal to, then come and write 2 roots of 5 times the whole of this, then minus 6 into the whole of this. Is allowed, but that step will not attract any marks. So here you can do it mentally. You know that the first term of your first factor will multiply all the terms in the second factor. The second term in the first factor will equally multiply all the. So you do that mentally. So it will be 2 roots of 5 times 6, and that will give you 2 times 3, which is times 3. So 2 roots of 5 times 3. So it will be 2 times 3. You multiply the non-radicand. So that will give you 6. Then root of, okay, what do we have here? 5. Then you come and multiply this and this, which is what I have here. I will get, the numerator will multiply. So I'll get 2 times 2, which is 4. 4 roots of 5, all over root of 5. Okay, but I could have more mature, so I could have cancelled. I knew that this will cancel, then I'll get 4 in the long run, but I didn't cancel, just for explanation purposes. So that's to mean that if you cancel, you would lose any marks. Okay, then now you come and multiply this to all the terms here. So minus 6 times this will give you minus 18. Minus 6 times this will give you minus 12 roots of 5. So this gives us 6. So this cannot be reduced. This you can't do, you can cancel this, and that will give you this. This must be kept. However, this equally we must work on, because after expansion, I can see a Z in the denominator, and I don't leave my final answer. I cannot leave my final answer to contain a fraction with a Z in the denominator. So this calls for rationalization. So I now write it and multiply both the numerator and the denominator by the Z in the denominator. So now I know that this is going to give me 6 roots of 5. Okay, this can be combined because I can see that they are obviously like terms. So 4 minus 18, that will give me minus 14. Then this will give me 12 roots of 5 all over what? 5, because this will give me roots of 5 times root of 5, which will give me roots of 5 squared, which is 5. So at this point, remember, okay, unless otherwise stated, anytime you are asked to simplify any expression and at least one of the terms contains, you have more than a term, but one of the terms contains a fraction, make sure you leave your answer as a single fraction. So by that, I know that this term contains, okay, a fraction. So I'm going to leave my answer as a single fraction. So I take the LCM. So if I take the LCM, remember this is over 1. Any term with no denominator, the denominator is 1. Okay, so what do? The LCM will be, okay, 5. Okay, so I asked myself, 1 will go into my LCM 5 how many times? 5 times, then times the whole of this. So 5 times this will give me 30 roots of 5. Okay, 1 will go into 5, 5. 5 times 14 will give me 70. By then I would have written my negative there. Okay, then, okay, minus will also come. 5 will go into 5. How many times? 1 times this. So that will give you exactly what you have there. So at this point, you realize that your numerator contains like terms, this and this. So you can combine. You cannot leave it here. After single fraction, check whether usually it is your numerator that could be combined or simplified. So in this case, I know 30 roots of 5 minus 12 roots of 5 are like terms, so I can combine. So it will be 30 minus 12, and that will give me 18, the root of what? 5. Then minus my 70 all over 5. So I draw my conclusion, okay, at this point. Okay, so that gives you, someone could have drawn the conclusion here, but like I advise, if you get a complete factorization, okay, sometimes, complete single fraction form, okay, sometimes it's possible you can reduce. So don't draw your conclusion there. Even if you come and write therefore here, and you write this and you realize that you can conclude, you can still keep your therefore, this is equal to, then come and write equal to again and leave your simplified answer as your last step. I hope my point is well made. Is my point well made, my professors?
Yes, sir.
Okay,
Yes, sir.
so this will be it for question B. And question B, the total marks for that will be 7. So take note of that. Okay, so can I move on to the next page?
Yes, sir.
Okay, all right. So this takes us to question, okay, C, okay. Question C here, we'll look at D and E. Okay, C, you can see that obviously we have 2 methods. One of them you are writing a lot. Okay, the other, so the one that will be convenient for you, you adapt. However, this will be the ideal way. Okay, so question C, what are we asked to simplify is this, so you extract. Okay, this is it. Okay, so here, unlike the other one that I said, usually if you have a binomial set, a set with a binomial denominator, where the denominators will be conjugates of each other, you take the LCM because you don't do we don't do rationalization with 2, okay, a binomial set in the denominator. So in this case, you extract B half. Okay, then you know that this and this, they are not conjugates of each other. So here I rationalize term-wise. So I come and rationalize this, which will mean I have to multiply numerator, denominator by the set in the denominator, then minus, I equally rationalize this, numerator, denominator by the set in the denominator. So that's what I have here. So that will be M1. So when you are multiplying, you have to be careful. So here, each of the terms in the numerator here will multiply the root of 3. So it will be root of 3 times root of 3, which will give you root of 3 squared, which is 3. Then plus 2 times root of 3, and that will give you 2 root of 3. That's what I have here. Then root of 3 times root of 3, and that will give us root of 3 squared, which is 3. You come and do same here. So with this one, keep the negative. This negative is affecting the whole of this. So keep the negative. Then now come and multiply each of them. So when you are taking the term here, in the numerator, the first term is positive and the second term is negative. Remember, this negative now is there. Okay, you don't take this to be negative and this also to be negative. The negative is multiplying the whole of this. So if you write it here, then it means when you are taking the values here, you take them with their original signs. However, if you want to move it inside, then the signs will change. Take note of that. Okay, so if you did that, you know this method will be M0 and everything will be A0. So now it will be root of 2 times root of 2, and that will give you root of 2 squared, which is 2. Then minus 2 times root of 2, and that will give you minus 2 root of 2. Then all over root of 2 times root of 2, then that will give you, okay, 2 in the denominator. So at this point, you can see that there is no Z in the denominator. However, you have 2 terms where the 2 terms, all of them contains, okay, a fraction, or there is a denominator apart from 1. I told you, even if you have one denominator which is not 1, other than 1, you know what you are supposed to do. Okay, you have to leave your answer as a single fraction. So that tells us that we are supposed to leave this one. Okay, you need to write a single fraction form of that. So what will be the LCM? You know, once they are numbers, getting the LCM will be easy. Is my point well made?
Yes, please.
Yes, sir.
Okay, so here, like I said, you take the LCM. Once they are numbers, okay, you should be easy. I mean, the LCM, you can easily get that. Okay, so now, what are we going to do? We are going to have the denominator to be 6, which is the LCM, obviously. So now, you ask yourself, 3 will go into LCM how many times? And it will be 2 times. So it will be 2 times the whole of this. Okay, but because one of the, you can see that when we were multiplying this, we did that, okay, I didn't show. I think I mean the other one. When you are multiplying and you realize that, okay, both terms are monomial, you can multiply straight away. But when you realize that one of the terms, okay, is more than a monomial, then you have to write it this way. Keep your monomial and put your more than monomial, okay, factor in brackets, just as I've written it here. If the bracket is not there, you are doomed. If you just write 2 times, okay, and you write this, you are doomed. Then it means the 2 will multiply only the 3. So take note. So 2, which is a monomial, the quantity that you are multiplying, one of them will be 2, which is the number of times this will go into this, then times this. So you put the binomial, this one in bracket, keep this one. You can even choose this one, put this one in bracket, choose 2, but it's not necessary once it's a monomial. You do same here. 2 will go into 6 how many times? And that will be what? 3 times. So it will be 3 times the whole of this. By then you have kept your negative. So 3 times the whole of this is what we have here. Now you come and remove the bracket, which we are expect. This will multiply all the terms here, equally multiply. But when you are multiplying, especially Prof. Judah, take notes. Okay, so this time this will give you 6. Okay, this time this will give you 4, okay, root of 6, root of 3. Okay, then this is negative. So when you are multiplying, each of them will be this negative 3 times this, negative 3 times this. Take note. So when you are multiplying, you take the sign. If you don't want to take the sign, then you have to keep the sign. And when you multiply, the brackets will not go. But once you take the sign and the number here, okay, when you are multiplying, the brackets must go. So minus 3 times 2, minus 6. Minus 3 times minus 2 root of 2. And that will give you minus 3 times minus 2. That will give you positive 6, the root of 2. So that will give us this. Now, after expansion, we can see that this will take care of that. And we have these 2 terms left. 4 roots of 3 plus 6 roots of 2. Don't forget your denominator is always there. Okay, it's the numerator that you are working on. But as you are working on, you should always write the denominator. If you leave the denominator out and work on only the numerator and you write equal to, and along the line you bring the denominator, you are wrong. Okay, all along you are working with fractions. So until you cancel a numerator and denominator, the fraction must be there. Okay, so at this point, okay, here, like I said, okay, after combining like terms, you can see that still what you have there can be simplified because your numerator terms and the denominator term that you have here, you can see a common factor 2. So 2 can go into 4, can go into 6, and this 6 as well. So you factor out what's the 2. So if you factor out 2, because you know that 2 can go into, that's your common factor, you can reduce. If you factor out 2, you know that 2 comes out of this, and you'll be left with 2 roots of 3. 2 comes out of this, and you'll be left with 3 roots of 2. So all over our 6. Now, you know 2 can go here, 3. So in effect, we are going to get 2 roots of 3 plus 3 roots of 2 all over 3. By then, this will go here, 3. So that gives you your final answer here. Is my point well made? Okay, Prof. Judah.
Sir, on the final answer,
Yes.
I got 2 roots 3 over 3 plus 2.
2. Okay, so you didn't remember I told you. It is advisable you leave your answer in which form? A single fraction. Even I've made that point clear today. So what you have there, is this a single fraction?
No, sir.
It's not. Okay, and in the lessons, I told you that if the question wants you to leave your answer not in terms of single fraction, the question will guide you. That's why you say leave your answer in the form a root of 2 plus, then you know that the question doesn't want you to leave your answer in the usual form, which is the single fraction. But here, the question didn't say so. So it means single fraction all the way. So you get all that you have there, but you won't get the final answer score.
Okay.
All right. So the final answer will be A0. Okay, just because you didn't heed, okay, advice. Okay, so my 1 mark, you've dashed it away just like that. Okay, so let's look at the alternative. The alternative, okay, you take the LCM, which is allowed. Okay, so after taking the LCM, you know, okay, root of 3 times root of, so that will give you, instead of writing root of 6 straight away, don't. Okay, write it this way so that you can, when you want to find out the number of times this will go into this, you can see that the root of 3 will go into your LCM, okay, root of 2 times. So it will be root of 2 times this, the whole of this. Then root of 2 will go into this, your LCM, okay, the root of 2 will cancel, so you'll be left with root of 3. So it's root of 3 times this. Remember, your minus will be kept. Then at this point, you come and expand the numerator and equally expand the denominator. Now that this has served its purpose, the reason why you didn't write it as root of 6 was that you wanted to easily see the number of times, okay, each of the denominators here will go into your LCM. So now that you were able to determine that this has served its purpose, so you now go and multiply. So you remove the brackets in each situation, each of the terms, numerator, denominator. So that will give you root of 6, okay, plus 2 root of 2, minus root of 6, okay, plus, okay, 2 root of 3. So you know that this root of 6 and minus root of 6 will go. So you'll be left with 2 root of 2, okay, then root of plus 2 root of 3. So at this point, you know you have a fraction with a z in the denominator. So it calls for rationalization. You cannot end here. So you multiply both the numerator and the denominator by root of 6. So that's the step here. So it will be this 1 times root of 6, which will give us 3 roots of 12. This 1 times root of 6, that will give us 2 roots of 18. Because it will be 2 times 1, which is 2. Then root of 3 times 6, which is what? 18. All over root of 6 times root of 6 is root of 6 squared, which is what? Okay, 6, or root of 36, which is 6. Okay, so m half. Now, what do? This can be reduced. So you set up to reduce it. This can be reduced. You set out to reduce that. So if you reduce this and you continue, this is what we are going to get. And even at this point, we are not done. So you can imagine the volume of work in this one. So the point is, okay, if you realize that your numerators, okay, your denominators, I should say, they are not conjugates of each other, don't take the LCM set straight away. Okay, make sure you rationalize term-wise. It will make your work a little easy. So now, this takes us to the continuation. Okay, and you still factor out and cancel, just as I explained in the other one. Because you cannot leave your answer in the partial fraction form other than the single fraction form unless otherwise stated. So this gives us what? The solution for C. Now let's quickly look at that of the D. Okay, that was, okay, I think the easiest. Or one of the easiest. So now you extract this, perfect. Okay, and I told you, you can choose to expand or heed my advice. Always reduce before simplifying. Keep this in mind. It might not always be ideal, just as you saw in the question 1, but it is always better, it's safer. Okay, I've told you sometimes it's better to play it safe than to go the ideal way. So now this can be reduced, this can be reduced. So I come and reduce that. But whilst I'm reducing these two, I can see that what I have here, none of them, okay, is not in its basic form. All the cells are in the basic form. So I can equally work on this by expanding. So I'm working on this, reducing it to the highest perfect square, 25 times 2. Highest perfect square, 16 times 2. Okay, so here I come and expand. Instead of writing it exactly the same as is, then, okay, I will expand. So whilst I'm working on these two terms, I'm also working on this term. Okay, so it will be minus 3 roots of 2 times this, please. So that will give you, this time this will give you minus 6. Root of 2 times root of 2 will give you root of 2 squared, which is 2, or root of 4, which is 2. Then this negative will come and multiply the negative here. So if you change the sign, it will be M0, A0. Take notes. You've lost your way. There is no way you can find your way back. If you find your way back, and that's magic, not math. Okay, so it is this time, this which will give us minus, okay, so plus 15 roots of 2. So now you are simplifying this. This simplifies into 5 roots of 2. This simplifies into, okay, 4 roots of 4, 2. But you know it's multiplying a quantity other than 1. So you put it in brackets. Here, bracket was not necessary because the quantity that is multiplying its coefficient, okay, 1. Then this gives you This time, this 12, this will give you your 15 root of 2, same. Then now you can see that, okay, you have like terms to combine. So you get 5 roots of 2 minus 20 roots of 2, and that will give us minus 15 roots of 2. Okay, then plus 15 roots of 2, so that will give you 0. So you end up getting minus 12. And this question, we even solved it in class. Okay, so that takes us to the last step. So you know that after combining like terms, you end at your final answer. So at that step, you draw your conclusion. Take note. And here you are dealing with expressions, so equal to all the way. If you use implication sign anywhere, remember, I will come to the penalties. That will be -1. So indirectly, I've told you. Or if you start with implication, I will give you M0, A0. You cannot use implication. At this point, you need to know when to use the implication and when not to. You should know. I've said more than enough. So if you fail to do the wrong thing, or the right thing, I should say, I will assure you that I will not do the wrong thing. I will mark you down. Okay, so the next question, I should say, question E, which is the last for the question 1. What do? We were given this and we were asked to simplify. So again, first step, make sure you reduce all sets. Okay, any set that is not in the basic form, reduce. Okay, so I know if I realize that it's not in basic form, I can reduce. So this will be equal to highest perfect square 4 times and perfect square 3. I can reduce higher perfect square 36 times 3. Okay, this cannot be reduced already in its basic form. However, so 25 times 3 all over. This can be reduced. Okay, this not. Okay, and this also can be reduced. And this question equally, we solved it in class. Okay, so at this point, what do? We are still in the reduction process. So this will give you 2 roots of 3. This will give you 6 roots of 3. This is kept. This will give us minus 5 roots of 3. Then again, this will give you 5 roots of 6. This is kept. Okay, then this gives us 4 roots of 6. So remember, your numerator, all the terms are like terms, so you can combine. So combine the coefficients and keep the common set, which is roots of 3. So 2 plus 6, 8, plus 1, 9, minus 5, and that will give you 4. So 4 roots of 3. Then the denominator, you can see the denominator, all the terms are, okay, like terms. Radicansels, radicansels, radicansels. So we can combine by combining the coefficients and keeping the set parts. So 1 plus 1, 5 plus 1 is 6 minus 4, and that will give you 1. So it will be 1 root of, 5, 6 minus 4, so it will be 2. So it will be 2 root of what? Root of 6. So that's what we have here. So simplifying the numerator and the denominator, you realize that this 4 and 2 can reduce because they are now radicals. So 2 will go into 4, 2. So it will be 2 roots of 3 roots of 6. Then you come and, okay, rationalize because you can't conclude here. Okay, because if you conclude here, you have a fraction with a set in the denominator, which I've told you, no. You cannot conclude with, okay, fractions of that nature. So it calls for rationalization. Numerator, denominator, and when you are rationalizing, please take note. At this point, okay, you don't, okay, rationalize here. If you rationalize here, this step will go, the m half will go. You need to write it again before you rationalize, just as I've done here. Remember, I told you when we were dealing with rationalization. So what do? It will be this times this, which will give us 2 root of 18. Then this times root of 6 times root of 6. That will give you root of 6 squared, which is 6, or root of 36, which is 6. So now you can't end here, though the denominator, okay, is now rational. You cannot, because you can further simplify. And by that, we are going to get, what do you call it? 2 roots of 18. And 18, we can simplify 9 roots of, and you can see that the 2 is gone because I reduce. The 2 here can go into the 3. So it will be 1, okay, over 3. So instead of, okay, I reduce this, the coefficient, and I was also working on the radicand. So that's how come I have this. So after that, what do? You get 3 roots of 2. You simplify this over 3. And this you can cancel now. Okay, so at this point, okay, you end up getting roots of what 2. And that will be your conclusion. Okay, Prof. Kojo.
So I actually thought with the when you are rationalizing, I actually thought the 2 will multiply the root of 6, making it 12, and the
Which one?
3 will
Which two?
the 2 root of 3.
This one and this.
Yes, the 2 then non-radicand.
Okay. We'll multiply this.
Yes, sir.
No, it cannot. You can see that this is an radicand, this is a radicand. They cannot multiply.
Okay.
Okay, so the non-radicals will multiply. If you look at this side, the non-radicand here is 2. If you look at this side, the non-radicand is 1. So it will be 2 times 1, then you write it, that is your 2. Then root of, then you come and multiply the radicals too. 3 is a radicand, root of 6 is a radicand, so that will give us 18. So that's how can you have the root of 18 there, and the 2. So you cannot multiply a non-radicand and a radicand. Because
Yes,
you
sir.
agree with me that the 6 here is a radicand. However, this 2
Yes.
is not. So if
Yes,
the
sir.
2 will go and multiply anything, it will multiply the non-radicand here, which is the 1. It's simply understood to be there, but we don't write it. So it will be 2 times
Okay.
1, 2, then root of that. Because any normal standing there has 1 before it. Usually we don't write. Okay, all right. So if that's clear, then I think we can move on. Are you done marking this one too?
Yes, sir.
Okay. Please, are we all fine? Okay, so this will be it
Yes,
for
sir.
question 1. Now we
Yes.
are going to look at, question 2. Okay, so question 2, these are, so we'll be looking at A and B here, then go and deal with. Okay, so this is what we have. Question 2A, let's see whether there is any salient part to underline, because that is always critical, in protecting our marks. So let's see. Okay, so in the question, what am I giving? Okay, I'm giving that, this is equal to this. Find the values of x plus y. Okay, all right. So in this case, I have letters involved in the form. I was not asked to leave it in any form. So I know okay, how do I? So it means if this is equal to this, then it means I need to express this one in this form so that I can compare and get my x and the y. If I know my x and the y, then I can come and sum, and get whatever the question is looking for. So the question is looking for, this, your x plus y, the value. Okay, very, very critical. Is my point well made, my professors?
Yes, sir.
Okay, so at this point, we are good to go. So we are going to look at, what do we have? We are going to, so you are, at normal sense, so you can underline this, but it's not necessary. You are finding the value of this. Okay, so like I told you, this is what we are giving you extract. Okay, you know what's the plan. Okay, before I can find x and y, these two values and therefore sum, I need to express this one in this form, then I compare. So I will take only this one, go and work on it, write it in this form, then go and compare. So if I take this, if I want to write it in this form, this one has no denominator. It's partial fraction. This one has, so it means it calls for rationalization. Okay, so I'm going to rationalize numerator, denominator. Okay, I multiply. So if you are working on only this, let us know you are working on it. That's why you can see taking. Otherwise, someone can work with everything as I go, like I told you in our previous lesson, then later compare, but that will be time wasting. So take this side, work it out, so it means you will not be writing this side every way, step on the way. You save time, however little. So now, multiply this binomial by this monomial. Okay, so it will be root of 3 times root of 5, and that will give us root of 15. Root of 5 times root of 5 will give us root of 5 squared, which is 5, or root of 25, which is 5. All over root of 5 times root of 5, which will give us the same value. Root of 5 squared, which is 5, or root of 25, which is 5. So at this point, you can see you don't have a z in the denominator. Okay, thank God, indirectly I've transformed. But my form, I can obviously see that it is in partial fraction, 2 terms, but here I have only 1 term, as every single fraction is considered as a term. Okay, it's a numerator that contains more than a term. Okay, so, but the whole of this expression is a single fraction, a term. So now it means I need to split. Okay, so what do I do? I'm going to have root of 15 over 5, then plus 5 over 5. That's what I have here. But if I look at the form, I can see that my non-set term, comes first. So I know this will give him 1. So I'll write the non-set term. Plus, this is the same as 1 over 5 root of what? 15. Remember, if you have A, okay, if you have A, let me say root of B all over C, we know that this is the same as A over C root of B. Okay, take notes. If you have AB over C, I can say that this is the same as A over C, okay, times B is the same thing. Okay, here I want the coefficients, which is the y, to be explicit, to be very clear. And here the numerator here is 1 over the denominator, which is 5, the root of what? 15. So if you compare, you can clearly see that x is equal to 1, which is this, and y is equal to 1 over 5. Okay, so at this point, what I was asked to find is what I draw my conclusion. So I cannot draw my conclusion by saying, therefore, this is equal to this. No. I was not asked to leave my answer. I was asked to find this. So that's where the therefore will come. So therefore, x plus y will be equal to 1 plus 1 over 5. Because this is a whole number and this is a proper fraction, you know your answer straight away. And that will give us 1 whole number, 1 over 5. If you take your answer to the corresponding improper fraction before taking it to this, that's okay. The step that you took it to the improper fraction will not give you any marks, but you get your final answer. However, if you took it to the improper fraction and you don't change it to mixed numbers, okay, you lost your way. You get the mark up to this point. So that you won't get the final answer, because I've told you times with that number that you avoid concluding with decimals unless otherwise stated, or concluding with an improper fraction unless otherwise stated. Okay, so that will be it for question 2A. Now let's look at that of the 2B. Okay, what are we asked to find? We are to simplify this, leaving this in. Okay, so there is a form that we are supposed to leave our answer. So remember, I've told you, anytime the question asks you to leave your answer in a form, underline the form. Very critical. So until you get your simplification in that form, you don't, okay, stop. And here too, the form contains unknowns. So that should tell us that, okay, when we get our simplified version in that form, we compare and attach the values of the unknowns. So that's exactly what I have here. So I have this over this. Okay, now I can see a binomial. A binomial said in the denominator. And what was the advice? Anytime you have this situation, core maths, you don't do rationalization where you have a binomial denominator. So I've told you, when you have that situation, it means go and take the LCM. The denominators there, you can see that they will be conjugates of each other. And by that, if I say conjugates of a set, a binomial set, it will be a set formed by changing the sign between the two terms. So if you look at this, you can see that the sign here, if you change this one, it will reflect the other one, which is plus. If you change this one, it will reflect. So it means these two binomial sets are conjugates of each other. They should have the same first term, same second terms, but difference in sign. And you say that they are conjugates of each other. And any conjugate set, when you multiply, you always get a rational number, which will come from difference of two squares. So now, if my point is well made, take the LCM. That was the advice, because you realize that they are conjugates of each other. Same first term, same second terms. Okay, so take the LCM. Now, you ask yourself, this will go into your LCM how many times? And it will cancel this, so it will be this number of times, then times 1. So it will be the same thing. You don't write 1 into this. You can choose not to. If you want to write, it's allowed. Only that you bring to bear your maturity in maths. Any number before 8, if it's 1, you don't bring it. Then you come to this. The LCM, this will go into the LCM. Okay, it will cancel this, so it will be left with this. So it will be 2 times this time around. The number that you are multiplying, none of them is 1, so you have to write and put this in brackets. So M2 for that. Now you come and remove this bracket. So you keep these 2 terms, remove the bracket. Positive 2 times this will give you 8. Positive 2 times this will give you minus 4 roots of 3. So at this point, you can see you have, after expansion, usually there will be like terms to combine. So 4 and 8 are like terms. They are non-set terms. So you add, you get 12. The set terms are also like terms because they have the same radicand. So that will give me 2 minus 4. That will give me minus 2 roots of 3. Then my denominator 2, at this point, I can expand. Okay, to accept its purpose. Okay, because if I write it this way, I will be able to identify the number of times my denominators will go into the LCM. So now I expand. And when you are expanding, I've told you, anytime you are expanding binomials, check whether they are special before you go and stress yourself. So special, even we realized that they were special binomials per experience. They were conjugate. That's the more reason why we took the LCM. So this will give you difference of two squares. First term, which is 4 squared, minus second term, which is minus 2 roots of 3 squared per experience. We know that this will give us difference of 2 squares. So numerator, if you simplify 4 plus 8, 12, and this plus this, okay, like I said, it will give you minus 2 roots of 3. Then the denominator, after you realize that it's coming from difference of 2 squares, if you expand, you get, okay, 4 squared, 16. Then this will give you 2 squared, which is 4. Then root of what? 3 squared, which will give you 3. So numerator kept intact. You can't simplify anymore. But this one contains brackets here. Remove. If you remove, you realize that you can simplify. And here, okay, because the question asks us to leave our answer in a form, and the form you can see there's not a single fraction. So it means ordinarily, okay, you would have concluded with a single fraction, but in a simplified form. You would have factored out 2, then cancelled. Okay, the 2 will come and cancel the 4. Go into the 4, not cancel exactly 2. So that you get, okay, here to be 6 minus root of 3 over what? Over 2. Okay, however, that will not be the situation that we are looking at now because of the form. So in the form, partial fraction, so it means we need to split this. So that will give us 12 over 4 minus 2 over 4 roots of 3. Then this will go here, 3. This will reduce. They are now radicals. You can cancel just as you can multiply. Okay, so this will give us what? 1 over 2 root of 3. You can't end here. If you draw your conclusion and you end here, you get a 1. It will be minus 1. Remember, I've told you, after leaving it in the form, if the form contains letters, compare and attach. If you compare, so don't write comparing, just write compare mentally. If you compare, the P is the non-sedic term, which is 3. Okay, then the Q is the coefficient of your SURD, and the coefficient of your SURD is what? Minus 1 over 2. So Q is equal to minus 1 over 2. And your R, take note, your R is what you have under the square root sign, not the whole of this. So R will be equal to 3. So if you get any of the values, even if you had this one right, but when you are comparing, you had any of the values here wrong, you still get your A1. You won't get the marks for the attachment of the values here because one of them is wrong, or at least one of them is wrong. Is my point well made?
Yes, sir.
Okay, so,
Yes, sir.
okay, all right. So, can I move on? I should give you some time to. Okay, if I can move on, you tell me, then I move on. Okay, I guess you said I should move on. Okay, so now to the last 2 questions. Okay, similar to what we've done anyway. All right, so let's go and look at what we are supposed to. So remember the total mass for this one 7, this one 10. Okay, and take notes of, I'll come to the penalties too. Let me say one of the penalties. Okay, you are still working with anywhere that you know you are dealing with steps and you leave lines in between that page, every page with at least one line, okay, left. When you are not moving from a sub question to another sub question will be minus 1 because I've told you to avoid leaving spaces between your steps. Okay, take notes. Okay, so now this takes us to the C. Okay, what are we asked to? Without the use of calculator or tables, evaluate this. So you know, immediately you see this, you hide your calculator. However, I've told you, when you are smart at a point, you can use the calculator. No one will know. Okay, so given this, okay, if root of 3 is equal to this and root of 5, correct, okay, to 3 dp. So this must be underlined. Very critical. So it means your answer must be left in the decimal form. So that's why I said avoid decimals unless otherwise stated. So here we cannot avoid because it is otherwise stated. Okay, so without the use of a calculator, you hide your calculator if possible to avoid any temptation. Like I said, you can use your calculator along the line, no one will. So I extracted, Given this, then the values too. So you can see I extracted with what? Semicolon, column, or what have you. But make sure this doesn't interfere with this. Okay, otherwise, if you write equal to here, it will assume whatever you have directly on top of it will be what the equal to is affecting. Or if you like, you can choose not to extract it, underline it. When you need it, then you go and fix, okay, take it and fix it. So you import your results, sort of, to avoid all troubles. Okay, so at this point, I realized that, okay, this set can be reduced. This can be, okay, I can't do direct substitution because, okay, I have to avoid that. I only substitute when the set is in the numerator, remember. So this calls for rationalization. Rationalizing, it means you are bringing the set to the numerator. Okay, so indirectly. So this gives you write again, you multiply numerator, denominator by the set here. Then this can be reduced. Okay, so 25 times 5, then this. Okay, this gives us root of 3 over 3 plus 5 root of 5. This, okay. Someone can choose to substitute directly here, but our advice, always simplify, write it as a single fraction before you carry out your substitution or substitutions. So here, not a single fraction yet, okay, but okay, no set in the denominator, and again, all sets are in their reduced form. But you can see that, okay, you can combine like terms, but because you have a fraction, combining a like term mentally becomes difficult. So take the LCM, which will be, this is over 1, remember, over 1 over 1. You can choose not to write it as you mature. So 3 will go into 3, 1 times 3, so root of 3. Then 1 will go into 3, 3 times this, so that will give me, because 1 is a monomial, it will be 3 times this. I can always do it mentally. So it will be 3 times 5, root of 5. And I know that this is a non-radical and a non-radical, they will multiply, so that will give me 15. Then I keep my root of 5. So that's what I have here. The same for this one. This will go here. 1 will go into 3, 3 times this. You keep your negative. So it will be 3 times, okay, 3 root of 3. Okay, and here I didn't put any of them in brackets because one of them is monomial. And I could do that mentally also because one of them is monomial. So that will give me, all of them monomial. Okay, so 9 root of 3. And that's exactly what you have here. So at this point, you can clearly combine the like terms here because they don't contain fraction now. Okay, so root of 3 minus root of 9, and that will give you minus, okay, 8 root of 3. But you can see, because this is positive, like I have advised, it's better you write a positive term first. Okay, so I write minus 15 root of 5, then minus 8 root of 3. You can equally write minus 8 root of 3 plus 15 root of 5 is allowed. But based on the advice and for consistency, write the positive first. Positive 10 first. So immediately you combine and realize that you are going to get negative. Okay, shelve your result and go and check whether the other one will give you positive. Write that one first, then you bring the one that you shelved. Okay, so at this point, okay, single fraction, but okay, I cannot end here. If the question didn't give me any values, okay, root of 5, root of 3, then I would have ended here. Okay, because I cannot further simplify. But remember, you were asked to leave your answer in the decimal form, so you go and substitute. Okay, so root of 5, you were given is this, you substitute. Root of 3, you were told. So at this point, you can use your calculator, no one will know. Okay, because you are multiplying a whole number in a decimal. When you are multiplying 2 decimals, then you know that you will need your calculator. So at this point, you end up getting this. Again, you are going to divide a decimal by a whole number, so you can use your calculator, no issues. Okay, so at this point, you end up getting exactly what we have, okay, here. And your first approximation should be 4 dp. Take notes. First approximation should be 4 dp. However, because this is 4 dp already, okay, this approximation, okay, this will not give you an approximated value. Your result will be 4 dp straight away. But you were asked to take your answer to 3 dp. So if you conclude with 4 dp, you are wrong. So at this point, okay, I underline, I'm protecting my marks. Okay, I need to leave my answer in 3 decimal places. Okay, so it means I cannot conclude with it. This is 1, 2, 3, 4. So in my conclusion, I will take it to the required approximation, which is the 3 dp. So therefore, whatever that I was given to is equal to, now 3 dp will be 1, 2, 3. Okay, the next number, or digit is what? Is hot. So I will add 1 to this, which will make it 2. So I'll end up getting 6.562. Okay, but take note, anytime you approximate, don't forget to indicate your approximation in brackets, whether required or conveniently. Once it's approximated, indicate your approximation in brackets. So here the approximation is 3 decimal places, and remember, you don't write decimal places in full. This is universally accepted, so 3 dp. You are fine and you are good to go. And now let's come and look at what the last one, which is the D. Okay, so the D, again, you are given the, just like, okay, the A also, the 2A. Okay, you are supposed to write this, okay, as a single fraction, a single term. Then you compare. Okay, so what do we do at this point? I will take, okay, this side, which is this. Okay, then I take the LCM. Someone can, rationalize straight away. But I took the LCM. If I take the LCM, I'm going to get, this is over 1. Okay, take note. So I'm guiding you to deal with it, okay, LCM wise. So the LCM will be, of this will be 1 times root of 3, which is root of 3. So 1 will go into root of 3 how many times? It will be root of 3 times root of 3. That will give me 3. Okay, then root of 3 will go into root of 3 how many times? 1 times 2, and that will give me 2. Okay, so already I have my minus here. So 3 minus 2 will give me 1 over root of 3. But I cannot end here. If you look at what I've been asked to compare, okay, my Z is in the numerator. So I cannot, the form, I cannot. So what do? I rationalize. If I rationalize, okay, write it again before multiplying numerator and denominator by the denominator here. So 1 times this will give me root of 3. Root of 3 times root of 3 squared, which is 3, or root of 9, which is 3. So at this point, I can see that this is the same as 1 over 3 root of 3. So if I compare, I will see that the m is the coefficient of the root of 3. So what's the coefficient of root of 3? 1 over 3. So I was asked to find m. So I draw my conclusion with what I was asked to find. Therefore, m is equal to 1 over 3, which is the coefficient. I'm done. So in all, if you sum, so this will be 6. If you sum, your total must be, okay, 33. However, I'm giving 2 bonus marks. But this is how I would distribute the bonus mark. Okay, if you get, okay, 30 to 31, okay, or 31.5, let me put it this way. Okay, you are going to get, okay, plus 1 bonus mark. However, if you get 32 up to 33, okay, you get a bonus mark. You get all the 2 bonus marks. Is my point well made? If you score below 30, which is even 29.5, you won't get any of the bonus marks. I guess my point is well made. And remember the penalties. Any page, okay, that you have a line left where you are not moving, you didn't write anything in that line, when you are not moving from a sub question to another sub question, you should know that it will be -1. So if you have 4 pages and each page you have at least 1 line not, okay, attended to, and you know that you are not moving from a sub question to another sub question, you are going to have -4. And again, if you start any of your steps here with the implication sign, -1. If you have more than 1 implication sign, then it will be M0, A0. Take note. All right. So that will be it for the solution to the class test. Okay, so God bless us all. Okay, so sorry, I forgot something. So please, this is how you are going to sum your score. If you had maybe 30, don't write 30 over the total on top of your first page, and it should be boldly written. Okay, boldly and clearly written. Don't write 30 just like that. Let us see your total marks, which will appear as a denominator. So it will be 30. If I had 30, I need to write 30, okay, over my total score, maybe 35. Okay, take note of that. Don't just write 30. You can choose not to circle it or underline. I just want to see this. That's okay for me. I guess my point is well made. So once again, okay, thank you very much for making the class, okay, a success, and God bless us all.